Hi everyone, and thanks for allowing me to be here. First of all, a little bit about my background. My name is Linqi Zhang from the Cyber Technology Institute, and it is an international part-time student right now in China. And back to the main topic. Today I'm going to share the part of my article I submitted to Expert Systems and Risk Applications journal some days ago on the topic of a taxonomy-based study of customer churn prediction from a data mining perspective. Actually, it is interdisciplinary research and is divided into 4 parts: introduction, method, data gathering, and discussion. Yeah, actually, the topic I'm going to share today is very close to everyone's life, and they're all customers, and we compare different brands and shops when choosing goods. For example, if I buy a new phone and I used to use Apple before, and now I have to switch to another brand. So for the App Store, I could consider a churner. So, like the customer churn, also referred to as customer attrition, it is the phenomenon in which the customers of a company stop buying goods from that company or interacting with it. So, predicting customer churn, maybe from the company perspective, the cost of selling to a new customer is 5 times higher than that of reselling to an existing customer. So, retaining existing customers reduce the cost of doing business, and in addition, maintaining long-term relationships with customers is essential to go ahead. And from the customer perspective, the overall experience is improved as companies often optimize their products and service to retain customers who they may lose, and these situations also saves customers time as they do not need to look for the new companies and products. Yeah, and actually right now many data mining techniques are used by the different companies to predict customer churn and can help these companies to extract the hidden pattern of useful information and to avoid the income losses. So consequently, research on these areas has been emerging, and right now there are many research of it, but the systematic review of this area is imperfect. Maybe some research are not focus on the data mining techniques, and some may not focus on the customer churn prediction, and maybe some are only in one area, such as telecommunications. So there remains a gap in the existing literature regarding the latest finding on the integration of customer churn prediction with data mining techniques. So the objective of this research is to illustrate the current state of the art in customer churn prediction and support the future research on the subjects. And based on the objective, a fundamental research question can be formulated, that is, how does data mining contribute to customer churn prediction? And to answer these questions comprehensively based on the data mining process, the following sub-questions are proposed. So because due to the time limitation, I will only talk about the first one, what data mining techniques can effectively predict the customer churn. And as for the method, we can see in the flow chart, I use the Scalper's search engine, and the keyword search for the abstract title and keywords products like the 415 candidates papers, and I set some inclusion and exclusion criteria, and after screening, the final 61 papers are selected, and the full scientific analysis is achieved by categorizing the content of the selected 61 papers into the 4 categories: determining evaluation metrics, input variables, and research area. Yeah, and the table is generated based on these 4 categories, and actually it is one table, but it's too big to fit in one slideshow, so I cut three parts, and we can look for this table. And the table lists the data mining techniques used in the literature. And in total, there are over 55 data mining techniques used in these articles, and some individual technicals and some hybrid techniques. And it can be divided into supervised and unsupervised techniques. And besides the k-means clustering, which is unsupervised, supervised techniques accounted for the most purpose of the data mining techniques applied in the selected publications. So among these techniques, the decision tree is the mostly common used. Actually, there's a wrong number. It's the 36, and followed by the neural network and the logistic regression. And like after see some main data, and we can move to the discussion section, and we can answer the first question, like what data mining techniques can effectively predict the customer churn. And the F1 score, AUC, and accuracy are employed to compare the results of data mining techniques based on the numbers of times the metrics are used and the characteristics of the metrics. And also for the choosing of the data mining techniques, decision tree, neural network, and logistic regressions are the top three most commonly used techniques. And the random forest and naive-based and support vector machines has recently gathered research attention. So we chose these 6 data mining techniques to comparison. Okay, there's some maybe. And this table presents the F1 scores for each technologies, and the extreme F1 score data of the articles 16 is removed from the analysis because it yields the lowest score is less than the random one. So from the table, we can see that the random forest performs the best overall and followed by the SVM. And the largest regression techniques performs poorly related to others. Actually, the random forest method exhibits good performance is because that the random forest is an ensemble method for the decision tree, especially when the samples use the very large numbers of input variables or when the largest data set are employed. So random forests perform better than the most single algorithms as they do not need to fall into the overfitting traps. And this is a table shows the AUC for each techniques, the naive basis. Okay, it's here. Algorithms performs worse than the other techniques, and the logistic regressions is also not very good. But the decision tree and random forest approaches performs best, followed by the SVM algorithms. And during the research, SVMs performs better performance when 50 to 50 sampling with a balanced distribution is used, and whereas the decision tree and random forest approaches performs better when oversampling on a full database. And the table of accuracy values for each techniques. And although accuracy is the most commonly used metrics if its sample is severely unbalanced, for example, the sample is 90% positive and 10% negative, the accuracy will be incorrect because accuracy is determined based on the numbers of the correct prediction as a percentage on the total sample. And according to the table, the random forest and the SVM method performs best, and the logistic regression and the naive base performance is poor. Actually, to sum up the main findings, the random forest techniques perform the best among the 6 techniques, and among the other single techniques, if a high F1 score is required, the best among of if the F1 is required, then the FIM is a good choice, and if a high AUC is necessary, then a decision tree also can be used. Actually, besides these 6 techniques, some hybrid algorithms could be used. Like as well as the above discussion, it can be found that the tree-based algorithms they often outperforms other algorithms. And also research shows that the backend neural networks could improve the performance of the neural networks. So maybe the research could use the backend and plus the random forest techniques to test the modern performance in the future. And also the evolution algorithms have the ability to adapt to different environments and deal effectively with complex problems that are difficult to solve with the traditional algorithm. So the evolutionary algorithm plus the decision tree maybe also can be worth discussing. Yeah, actually, this is one part of my research, and it is some basic findings. And these areas I begin to research this year. So maybe just some basic knowledge aspect. So if you're interested in this topic, that we can contact from email. Like, thank you. Yeah, this is what I want to say.